All right, this will be video for 7th grade. We're going to do lesson 12.4. We're going to make predictions with experimental probability. In this lesson, we're going to calculate percents. We're going to apply percents. We're going to just solve a lot of percent problems for probability. So we're going to use experimental probability to make a prediction. So for example, one here on this page, this is page 387. Scientists study data to make predictions. You can use probabilities to make predictions in your daily life. Danae found that the experimental probability of her making a bullseye when throwing darts is 2 out of 10, or 20%. Out of 75 throws, about how many bullseyes should she make? So we can solve this in two different ways. She knows that it's 20% or 2 out of 10. So how many out of 75? We can solve this with a proportion. We can say that 2 out of 10 is equal to how many out of 75. In fact, that's what they're doing right here. 2 out of 10 is how many out of 75. So we've got 2 out of 10 times some number. 10 times what is 75? Well, in order to do that, you do 75 divided by 10. We learned that this is 7.5. So from 2 to whatever we get for x, that's also going to be times 7.5. 2 times 7.5, 2 times 7 is 14. 2 times a half is 15. So she should get it 15 out of 75 times. Now, a second way we could solve proportions, the second way we've done proportions, gotta clear all that. The second way is using decimals and multiplying. Percents could be an equation. Write the equation to find 20% of 75. So it's 20% of 75. Of means multiply. So we're going to multiply. 20%, we can't really use 20%. We can't do 20 times 75, so we need to convert this to a decimal. So we move our decimal 2 times over. This is 20%. 0.20 times 75. So put our 0.20 right here. 0.20 times 75 is 15 again. So let's try a different example down here on the bottom. We've got a car rental place. Car rental company sells accident insurance to 24% of its customers. So it's going to 24% of the people. So we have 24%. Let's solve with a proportion first. Out of 550 total, how many are predicted to get insurance? Well, 100 times what is 550? From here to here, we do times, well, you do 550 divided by 100. That'll be 5.5. We'll do the same thing here, times 5.5. 24 times 5.5, we get 132. Now, the other way we could do this, the other way we could solve this problem is we could do 24%. We could change it to 0.24, 24% of 550, and we're going to get the same answer. Okay, so you can always go from that percent to decimal and then just multiply because it's of this customers. This customers were 550 of them. So we've got number 1 solved. And in fact, this is pretty much how all of our problems are going to go. The only thing they're going to add to this is they're going to have people who have made a guess. So like a car rental company says that about 150 will buy insurance. It actually happens to 24% of the customers. Is this accurate? So we're going to have to just check people's work. So using experimental probability to make a qualitative prediction. The doctor's office records data and concludes that on average 11% of its patients call to reschedule appointments in a week. The office manager predicts that 23 out of the total 240 appointments will be rescheduled. I'm not even reading this, I'm just summarizing. The office manager predicts that 23 appointments will be rescheduled out of the 240 total appointments during the next week. So they say 23 out of 240. We want to know, is that accurate? Is that about 11%? Well, what is 11% of 240? Well, we can do 0.11 times 240, or we can solve this proportion from here to here. It's times 2.4 times 2.4. 11 times 2.4 is 26.4. 23.4. So they say 23 will reschedule, but the actual expectation using our percentage, our 11%, should be 26.4. So let's decide, is that accurate? Let's see, 26.4, it's reasonable. This is what it should be, and they said it's going to be 23. I think it's reasonable to predict that. We're only off by 3, right? But it is a little bit low, and I think we should mention that. It's close, but their prediction is a little bit lower than the expected outcome. The expected outcome is 26.4. So let's do the example down here on the bottom. In emails to monthly readers of a newsletter, 3% or 0.03 of the emails, we're going to have a number for amount of emails in a minute, come back undelivered. The editor predicts that if he sends 12,372 emails, he will receive 437 notices for undelivered email, and we need to decide, do we agree with that prediction? Is it right? Well, let's find out what 3% of 12,372 is. 0.03 times 12,372. We get 371.16. Do you agree with this prediction? So this guy said it's going to be 437. What we actually calculated was 371. So this prediction is a bit high. It should be around 371 undelivered emails. And that's good enough. So it's just a little bit high, because he said 437, but it was actually 371. Gonna clear this out and go to the next page. Next page. We're gonna do this entire page. Okay, so on average, 24% of customers who buy shoes in a store buy 2 or more pairs. So 24%, that's 0.24. On a weekend of customers, so that's 350 people purchase shoes. How many can be predicted to buy 2 or more pairs? Well, let's find out what 24% of this big number is. 0.24 times 350. This should be about 84 people buy 2 or more pairs. We should predict, we're answering the first question, how many can be predicted to buy 2 or more pairs? Predict 84 customers to buy 2 or more pairs. Question number 2. If 107 customers buy more than 2 pairs, did more customers than normal buy 2 or more pairs? More bought, no, how about more than normal? Because normally it's 84, in this case it's 107. Bought 2 or more. All right. Scrolling down, clearing my writing. Number 1, we're going to do 1, 2, 3, and 4 here. Move me down for number 1. Number 1, a baseball player reaches first base 30% of the time he is at bat. That's 30%, 0.30, or just 0.3. Out of 50 times at bat, about how many times will the player reach first base? So we're going to do 0.30. 30% of 50, we get about 15 times. Number 2, the experimental probability that it will rain on any given day in Houston, Texas is about 15%. Out of 365 days, about how many days can residents predict rain? I'll do this one with a proportion because we've been doing the decimal form quite a bit. So 15% out of 365 What is 15% of 365? Well, from here to here, 365 divided by 100 is 3.65 times 3.65. So we do 15 times 3.65. We get 54.75, or about 55 days. Number 3, a catalog store has 6%, 0.06 of its orders returned for a refund. The owner predicts that a new candle will have 812 returns out of the 16,824. 16,824. So they're predicting we're going to have 812 with this. But let's check it out actually. 0.06 times 16,824. We get 1,009. Do you agree with his prediction? His prediction is low. It should be around 1,009 returns. Prediction was pretty low, wasn't it? Number 4, on a toy assembly line, 3%, 0.03 of the toys are found to be defective. The quality control officer predicts that 872 toys will be found defective out of 24,850 toys made. So let's multiply this by 24,850 and find out the actual number and compare it to their prediction of 872. So 0.03 times 24,850. This is 745.5. This again is kind of low. His prediction is low. It should be more around 746. All right. This is the actual amount using the 3% number. And this guy, the quality control officer, predicted a little bit too. Oh, his prediction is not low. His prediction is high. Whoops. Did I do that right on this one? He says prediction is low. Okay. He guessed a little bit too high. Or she. He said 872, and it's actually 745. So it's just a little bit high. 5, 6, and 7. All right. Number 5, a light rail service, it's like a train, claims to be on time 98% of the time. Jeanette takes the light rail 40 times 1 month. How many times can she predict it will be on time? Well, if it's going to be on time 98% or 0.98 out of 40, well, let's figure it out. 0.98 divided by times 40. It should be 39.2, so it should be 39 times. It should be on time. How many times can she predict? It should be on time 39 times. Is the light rail's claim accurate if she is late 6 times? It should only be late 1 time, so the claim is not accurate if she is late 6 times. Yeah, it's not really going to work. She should be late 1 time if they say 98% of the time. So they're wrong. They're kind of lying. False advertisement. Get a refund. Number 6, on average, a college claims to accept 18% of its applicants. 18% is 0.18. If the college has 5,000 applicants, predict how many will be accepted. 0.18 times 5,000. It should get about 900. If 885 applicants are accepted, is the college's claim accurate? Well, I think that 885 is pretty close to 900, so the claim... Wow, that says a word almost. All right, quit it. The claim is accurate, but maybe a little bit high, because they ended up going a little less than that, but it's pretty close. 18%. What's 17%? Yeah, so 17% would be 850. So it's pretty close. I'd probably round it up to 18%. They're just, maybe it's 18, maybe it's 17.6 or something. I mean, it's pretty good. It's pretty accurate. Number 7, how do you make predictions using experimental probability? So the first way is we can solve a proportion to compare results to percentages, percents. Number 2, we could also change to a decimal and multiply by, well, let's see, what are we going to call this 5,000, by the total amounts. To make a prediction, so we can do those two. That'll give us the percents, or the amount that we should predict. We can use percents to predict how many times things will happen. And that's like with our 1 and 2. Kind of a long answer, kind of a vague question, to be honest, but I think we kind of covered it by summarizing everything we've done today. Let me know if you need any help or have any questions on any of this.